everyone. My name is Iris.
My name is Qingyi.
Today we are recording our interview video, and we are going to explain about our assignment, which is question number 5, which is to random generate a sparse graph and dense graph, which represented by the matrix at least to identify the breadth-first search and depth-first search. And now let's continue. Let's proceed to our computer and explain about some output.
Here, now this our code, and here this one is for adjacency list class for generate the sparse graph. We use the adjacency list to show the sparse graph, and here is the adjacency matrix. We use this for display our dense graph. Here is the code, and this one is for the depth-first search graph. We using the adjacency list and the adjacency matrix to generate this depth-first search graph. After that, this one is breadth-first search. We also using the adjacency list and the adjacency matrix to generate the breadth-first search graph. And here is the main integer main. We using the random generate to generate our number of nodes, which range more 10 plus 1, which will ensure that we won't have 0 node, which means our node, the number of nodes sure will at least 1 node until the maximum node is the 10 node. So now we run our code. This one random generate 1, so there's no any valid edges for this one. So the dense graph show the F means there's no connecting edges. Yes. And this one sparse graph for 0 node and not 0 also don't have any valid edges. So if we type 0, then here will all show 0. Then we run again to show another output. For this one don't have any valid edges, so this here show F means false, and the code is here for the matrix maximum number edges for matrix. We set the maximum number edges matrix equal to number of nodes to the power of 2, means number of nodes times number of nodes. Then for the maximum number edges for list, we just using the number of nodes. Here we'll show we take the random generate the origin, and we random generate the destined. From here, if origin means this one less than the number of nodes and the destined less than the number of nodes, and the origin must bigger or equal to 0 and destined must equal to 0, then just will see out the origin. Just show here just show valid edges only, means we just take the this one is the condition. Here is the condition, so we just get the valid edges and push into our list. Here for the adjacency list, we set this one for number of nodes, so we also random generate the origin list, and we also random generate the origin and the destined, and we also set the same condition as our adjacency matrix. Here, then we just push in the valid edges only to the vector or any list. Then now we run again this code to show another output. Here, the number of nodes random generate is 10, and the edges you can see from here 0 from 9, not more than 10. This all is the valid edges. all is the valley edges. The maximum is 99. For the dense graph, how we generate the depth first search is like from you can see the result. We can see from here the 0. And this one is for the edges, valley edges for sparse graph, which we show in adjacency list. From here you can see 3, 7 is 3, 7. After that is 3, 6. So the 7 will push back, and the 6 will in front of the 7. And this one is 7, 5. After that is the 7, 7 means 5, 7, 7, 0, 7, 0. Then here is 6, 7. So 6 to 7. 1, 7 is 1, 7. After that is 1, 2. The 2 will in front of the 7. Then this one is 0, 1 only. And this all means that they don't have any connected edges. Now we can enter the starting node to show our depth first graph and breadth first graph. This one because the starting node is 0 until 9, so we do a error checking here. If we input 10, then it will show us the error message. Please enter again, thank you. Then we enter the correct node, means we starting from 0. Then this is for the depth first search. The answer is 0, 2, 4, 1, 3, 7, 5, 6, 8, 9. Now we show how we do this. For the depth first search using the dense graph, which we using the matrix to show. From here, the answer is 0, 2, 4, 1, 3, 7, 5, 6, 8, 9, which means with this one 0, 2, 4, 1, 3, 7, 5, 6, 8, 9. And now we show how we do this. From here, 0 and 0, 0 to 2 for the depth first search. So here we'll 0, 2. After that we show, because this one is depth first search, so we look at the 2, 2, 0. But 0 visited already, so we look at 2, 2. But 2 also visited, so we look at 2, 4. After 4, we look inside 0, 4, 1. 1 haven't visited, so we write 1. After that, we go back to the 1. 1, 1, 1 is visited, so we go to 1, 3. So 3 haven't visited, so we write down 3. After that, we go to 3. 3, 0 visited, 3, 1 visited, and 3, 2, 2 visited, 3, 3, 3 visited, 4, 4, 4 already visited, so we go through 5, 6, 7, 3, 7, so we write down 7, 7 haven't visited, so we go to 7, 7, 0, 0 visited, 1 visited, 2 visited, then 3 is 4, 4 is 4, 5 also 5 haven't visited, so we write down 5. After that we go back to 5. 0 is visited, 2 is visited, then 5 is visited, so we go to 6, so we write down 6 haven't visited. Then we go to 6. 0 visited, 3 visited, 4 visited, 5 visited, 6 visited, 7 visited, and then we write down 8. Then we go to 8. 1 visited, 2 also visited, then 5 and 6 also visited, then we go to 9. After that, we look at the 9. 9, 0 visited, 1 visited, 2 visited, 4 also visited, 5 also visited, and then 8 and 9 also visited. So this is the correct output for the depth search using the dense graph, which we using the adjacency matrix to show our dense graph. Then here is for depth search for using the sparse graph. Now the depth search is 0, 1, 7, 5, 2. Here depth search using the sparse graph to show which is 0, 1, 7, 5, 2. Now we show how using the sparse graph. For this one, sparse graph, with the starting node is 0, so 0, 1, 0, 1, or we write out 0, we write out 1, because these two haven't visited, so we write out 0, 1. After that, we look at 1, 7, because 7 is the first node enter. So we look at 7. After that, from 7, we go to the first node of 7, which is 5. So we write down 5. After that, we look at the 5. 5 don't have any connected edges, don't have any connected node. So we go back to 7, and then here we go back to 1, which show these two haven't visited. So the correct output is 0, 1, 7, 5, 2. 0, 1, and then 1 into the first node, which is 7, and then 7 to 5. The first node of 7 is 5, and then 5 don't have anything, then we go back to 1, which is we take the 2. Can finish.
Okay, now I will continue to the breadth search by using the dense graph. How we identify it, now I will explain over here. Okay, let's say for the first one, the starting node is 0. The starting node is 0. Okay, let's check whether which node have been visited. Okay, so 0, we got 2, which is true, 2, and Q8 visited, set it visited, and then 6 visited, and then 7 visited, and then 8 visited. Okay, now 0 has been visited all. Okay, let's DQ it. So we mark X there, we DQ this, and we check number 2. We got what? We got first one, true is the 0. 0 we already set it visited, so we ignore this. And then after that, 2 also visited, so we ignore this. And then 4 is a node that we haven't visited yet, so we enqueue it to the queue. So it's 4. And then 5, check our queue list, it's also not exist and it's not visited yet, so we enqueue this. 5, 6 already visited, 7 already visited, 8 false, no, 9 is true, not visited yet, and we enqueue this. 9. Okay, so 2 done checking, we DQ it. Okay, 6, now we check 6. 1 haven't visited yet, 0 visited already, so we mark a X there, and then we ignore this. 1F, and then we check the true only lah. So the number for the node 3 is we haven't visited yet, but then it's true here, so we enqueue it to the list 3. And then 4 already visited, 5 visited, 6 visited, 7 visited, 8 visited, 9 visited. Alright, so now 6 done, we DQ it from the queue. 6 done. Okay, we check number 7. Number 7, 0 visited, so we ignore this. 1 not yet visited, right? So we enqueue it to the queue. And then after that, for the 2 visited, and then for 5 visited, 6 visited, and 8 visited, 9 visited. Alright, so we check one by one. Then now is 8. 1 visited, 2 visited, 5 visited, and 6 visited, 9 visited. Alright, so now DQ 8. 9. 0 visited, 1 visited, 2 visited, and then 4 visited, 6 visited, and then 8 and 9 also visited. So done. We DQ it from the queue, and then we check 4. 1 visited, 2 visited, and then 6 visited, 7 visited. Right? So we DQ it. 5. 0 visited, 2 visited, 5, 6, 7, 8 also visited. So we DQ it. And then 9. We also check here. 0, 1, 2 visited, 4 also, 5 also visited, and then 4 also visited, 5 also visited, and then 8 and 9 also visited. Then we check 3. 1, 0, 1, 2, 3, 4 visited, and then 7, 8, 9 also visited. We check 1. 1 also visited, 3 visited, 5, 6 visited, and 8 also visited. Done. Here is our queue. Let's check the output whether it's correct or not. So we will get 0, 2, 6, 7, 8, 4, 5, 9, 3, 1. So this is the correct output. For the sparse graph, for the breakfast search for sparse graph, and we are now checking whether the output is correct or not. Right? 0, 1, 7, 2, 5. In order for us to check whether the output is correct or not. Alright. For the starting node, this was 0. And then we can know that starting 0, and then we enqueue the 0 first, and then after that we mark it visited, and then we go to 1, it's point to 1, and then we go to 1, we check 2, 7. I think just now Chini already explained why it's 2, 7, right? 7 come first, and then 2. Alright, so the one who comes first, we will enqueue it to the queue, which is 7. We enqueue it, and then after that 2. So now let's go to 7 to check. 7, 0, so it's 0, 7, 5. 5 come first, and then after that 7, and then after that 0. 7 and 5 is already visited, and we enqueue 5 first. 7 and 0 is already visited, so we ignore these 2. And after that 5, let's go to 5 to check. 5 has nothing, then the program will exit 0, 1, 7, 2, 5.